Newton's third law of motion. Newton's third law of motion says when two objects interact each other, the force exerted on one object is equal in size and opposite in direction to the force exerted on the other object. Okay, you can watch this video. Let's watch this video a little bit, and since the video time. Okay, so then. Okay, well, to limit.
Studying physics is the interaction between objects. Check out this interaction between these objects. Great job, guys. Now, who felt a greater force in that interaction?
Well, I guess I did.
Well, actually, according to Newton's third law of motion, it states for every action there's an equal and opposite reaction. You both felt the same force. Let's demonstrate with the scales.
All right, let's stop here. I will let you. Okay, you must watch the whole video and watch more if you want. So, formally, the magnitude of the force, one exerts A due to B and B due to A are the same, supposed to be the same force. But one thing to notice that they are exerting on two different objects. So A apply on B, the force is on B. At the same time, the other object will exert force back, or B will exert on A, and then it will be the same in magnitude and the equal and opposite reaction. Okay, so another concept related to this is called momentum. Okay, the product of mass momentum is defined basically if you use how much motion is there. The heavier object, they will have stronger motion, and lighter object, less motion, depending on the mass. Obviously, if it's faster, it has more motion. Okay, and even faster, it's more motion. So the momentum is depending on the mass and the velocity. Therefore, and momentum is actually a vector, has directions. So momentum is mass times velocity. Okay, because of Newton's law, since the force is responsible for velocity change, that causes the acceleration, but Newton's third law says if this object pushing this direction, at the same time another object, for example this marker, it will push back. Therefore, the momentum is conserved because its velocity increases that way, and the velocity will be decreasing this way. The total momentum as a whole will be staying constant if the interaction is only within these two objects themselves. Once again, momentum conservation says this: if the system has no external force, which means the interaction is just between these two objects, the total momentum, it will be staying constant. So the momentum of this one, velocity times its mass, and momentum of this one, the velocity of its mass, is added together, will be a constant. Doesn't mean they will individually be changing, but the nature that their interaction is all equal and opposite direction, so the total will remain same. For example, if the two things move this way, hit, and the momentum of this one will increase, the momentum of this one decrease, but the overall as a system will stay the constant. That's the idea of momentum conservation. We'll have some exercise on Newton's third law and momentum conservation shortly.